Hello and welcome back to another dive stream. This is number 869. This is live footage from the remotely operated vehicle Sebastian, touching down just shy of 775 meters below the surface of the ocean. It's another kind of soupy dive. I don't know, there's definitely a lot of matter in the water. Pretty productive, this area, so we'll see what we find. Definitely a lot of fish here to greet us just now. But I'm going to turn the other mics up in mission control, and you'll be able to hear the activity here as we dive. Get this little guy for me, please. He's a cool little, got a little Oreo fish here. He was faced away from us, giving us a really weird profile. So, all right, going to turn the other mics up here and enjoy.
Everyone, this is Brett Baker from University of Texas, Austin. This is a good example of what we call the biological carbon pump, where you see on the way down, if you were watching earlier, there's a lot of marine snow. What we call marine snow. It's essentially organic matter that's raining down from the overlying water column, and mostly it's produced in the surface ocean by phytoplankton, and then these sort of clumps together and then falls down, and there's this huge flow of organic carbon from the surface water to the sediments. This has a huge impact on our oceans and actually the global carbon cycle. We're diving into a canyon today to collect sediment cores as our primary focus, but we're also going to get some water. So we're going to be again looking for Asgard Archaea, a group of microbes that are our microbial ancestors. Happy to answer questions if you want. I do. Thanks.
You're all logged in. Okay, sweet. Enjoy.
Not seeing those bumpies anywhere.
No.
I think it's an artifact.
All right. Hello, everybody. We just changed our science party watch. So we had Brett tag out and Natalie Sarno, and now we have Daniel and I. So my name is Ian Hughes. I'm a grad student at Harvard, tagging along to help out on the expedition. And yeah, Daniel, you can introduce yourself if you like.
Hi everyone, I'm Daniel Milstein. I'm a graduate student at the University of California, San Diego. I'll be the sea logger for Ian. For these features.
Just trying trying to toy with the lights there a little bit. It's kind of like driving in a snowstorm. Just getting the right balance of illumination and backscatter. You don't want that backscatter shining back, but at the same time we need light to see, so it's a balance. I mean, it's dark, but like, so at this point, right, whatever you guys need, just see. I would say go for it without blowing it out.
That looks better. Just about that more ISO. That looks a bit more even.
It's a very pleasing palette.
I know.
I really
I
like
like
that
it.
gradient. We need this as get that on there.
That's not how that works.
It's pretty close. Actually, it's pretty close. It's
Pretty
just
close.
inverted.
Yeah, this is called
That's
bat.
No,
This is the scientific color.
is this one better? Oh,
See, the thing is, what's
that's
the other one on the
Yeah.
except for this shadow
on the giant list.
right? Which I'm not sure what that's coming from.
I downloaded a specific color.
I know.
Scientific colors.
Oh, I like this one as well.
This?
Yeah, those. Maybe just dots that are lower in it. Just get them up.
Did you do it?
Yeah, earlier. But
In the center, and that mouse
Are you
all up.
cheating?
Yeah, let's do that. One I think is better than just start with one.
how's the background on?
I'm not.
Whoa.
Convinced these outliers.
They're good when you're on the sheer faces, but
Oh yeah, that is up.
Yeah, I like
yeah,
that.
it's
Okay.
It's Hawaiian.
Actually, do you pull up that
I like
site
that.
and all that?
Batlow is pretty standard.
That looks good.
What do you think, Alec?
Batlow's
What you got? It's like the optometrist, so you're asking like 1 or 2.
Yeah.
One
Just
is about the
better.
same, or 2.
There is no difference.
There's no difference.
Oh, wait. Even not that one.
No, this one. This is one you just said was good for your palate or something.
They said it was pleasing.
Your pleasing
Yeah,
palate.
well, I didn't know I could have the outers.
Yeah, now that she's seen better, I can never go back.
But then, do you know if they got leaves or shadow in the middle?
I think it does actually.
Yeah.
Yeah. The cats put real low.
Yeah,
All right,
this I
yeah,
like.
that
This I
one.
prefer.
Fine. Fine.
Fine.
It's not sad, but like, one is actually continuing on.
All right. Well, it looks like we have a general current consensus on our lighting situation, which is good. Although subject to change if we have other cool stuff. Yeah. So today we're mostly working our way up this little canyon, which is sort of right on the edge of the continental shelf off the coast of Uruguay. And those of you who are just joining us on our first dive of this expedition, what we're trying to do here is look for Asgard Archaea. So Archaea are microbes. They're very small. They're prokaryotes. And what's really cool is that some recent work has shown that we think that these Asgard Archaea, we're really quite confident, are our closest microbial ancestors. So many years ago, well over 1 billion years ago, the sort of eukaryotes evolved. So we went from just sort of prokaryotes to eukaryotes, and so we think that our closest prokaryotic ancestor is one of these Asgard Archaea. And so we're doing a lot of work to try to figure out sort of the details of how this works, how we sort of went from just prokaryotes to prokaryotes and eukaryotes. So we call that eukaryogenesis. And of course, that was a really pivotal moment in the history of life on Earth, because it facilitated, a lot of complex life and a huge amount of diversification, lots of different types of multicellularity, all kinds of things like that. And so if you're happy that you are large and can do a lot of things and eat a lot of yummy food, you can thank the Archaea, because it's all because of them. And we're trying to figure out sort of how that eukaryogenesis initially evolved. So it may not be quite as charismatic as some of the other research that's done on some of these Schmidt expeditions sort of outwardly, but we love push cores, and and a lot of the really fun science happens back in the lab, but we've been able to encounter a lot of cool animals and other fun stuff along the way. So stick with us as we explore up through this canyon and look for good spots to sample sediments and look for our Asgard Archaea. So for some questions in the chat, ahora estamos casi 200 kilómetros este de Uruguay, de Punta del Este o La Paloma, no sé, y gotta look at the map. Yep, 200 kilómetros este de Uruguay. I do have to say, I live in Boston in the US, and I was very happy about leaving Boston this time of year because I get to escape the snow, but it turns out that even coming all the way down to the southern hemisphere, we're still running into a fair bit of marine snow that is causing a bit of interest, but we can see all these little fish they've got some very full bellies, so I think they're eating pretty good, which is very likely a result of all the organic material and all that kind of stuff. Lots of good things to eat if you're a deep sea fish. So we got a nice little ctenophore here, just bouncing along, looking for particles and things to eat. We've seen, those of you who joined us earlier on the dive as we descended, there are a whole bunch of these guys that are floating around here. We have a ctenophore expert on board, Jacob, but he is not currently in the room. But he's pretty good at identifying all these little guys, and so he'll be on a little bit later if you're really interested in asking your ctenophore related questions.
Yeah. But yeah, it doesn't look real. Yeah, multiple noise. Yeah.
Sometimes when you go off a cliff, it'll drag that with you a little bit, which is
Okay.
like a known error, but
Yeah.
if you're ever curious if something's real, you can take a look at it through the view.
Okay.
Sometimes that'll be able to edit that out.
Okay. Thanks.
Yeah, so we're right kind of at the mouth of the canyon at the moment, and so usually we like to dive deep to shallow. So if you're going like on sort of the edge of a shelf or a platform or something like that, you know, you go all the way down and then you kind of work your way back up. And so we drop down sort of right at the mouth of the canyon where it opens up, and y'all can see a little bit of that map. And our first sort of black dot is a waypoint, if you can see it on your screens at home. So we've just dropped down at the first one, and we're heading sort of up the canyon. If you look, you can hopefully see sort of our next target of what we're looking for. But you can see there are a lot of particles in the water, which is
Dustier and dustier.
That's heavy.
Don't go in a sandstorm.
No.
Maybe that's what the multi-beams do.
Wow. It's getting more intense. Seems like.
oh yeah.
Yeah, it won't do noise off the ground still, but
Yeah. Okay. See this guy?
So if you saw that little red jelly, it's kind of a fun fact. So as many of your longtime streamers or various marine biology enthusiasts may know, we have different sort of light spectra attenuate differently in the ocean, and so red light gets absorbed really, really, really quickly, and blue light has gets to kind of stick around and penetrates quite deep into the ocean. And so if you're wondering, like, why would you be red as an animal, why would you put necessarily the energy into producing red pigments and things like that, and it really turns out that actually, because sunlight doesn't really penetrate this far, anything that's red basically just shows up as black on the background in the ocean,
See him?
this deep at least.
This guy.
Fish.
Fish. Yeah, we're not a huge fish expert crew here in terms of our science party. A lot of microbial folks. So there might be folks in the chat who might be able to tell you a little bit more about the identities of some of these fish. Shot in the dark, I'd say it's probably some kind of gadiform, but again, I'm more of an invert kind of guy. So either way, it looks super cool.
He's got his feelers out.
Oh yeah. He's eyeing us.
Mr. Mustache. Mr. Mustache.
Perfect for No Shave November.
At least someone's participating in payments.
he's right.
Brent, do you want to core here area before we go too far up? Before we go, we want to get something deeper here, but I don't think we're in any rush. We're not really going up yet, so
Sweet.
just keep going for a while.
It's definitely it.
Yeah,
Yeah, that might be what the multi-beams are.
yeah. That's what I'm wondering.
What's the current?
Yeah, I wonder what that little fella is.
A jellyfish. Brown.
Something very gelatinous. I think it is, yeah. It's just a poor little guy landed upside down and
Saber jelly.
Whoa.
That's what? Nero? I texted him.
It's like room temperature air coming out of that sucker.
Systems are failing.
Should I sound the general or?
Yeah. Systems are failing.
Whoa.
my God. For el pregunta en el chat, I don't know. How tall is the top of the canyon?
It's like 500 meters, I think.
Okay, all right. So like ahora estamos casi 800 metros
Actually, that's
de
the slope,
profundidad,
yeah,
pero vamos a 600 metros.
That's what I'm wondering. I'm wondering if we shouldn't just get cores before it gets more.
I mean, you don't know what's going to come up.
Yeah, I think maybe we should. Why don't we get half the cores now? We know we can.
I can tell you're itching to do it.
I mean,
Yeah.
I mean,
Yeah,
Better than the alternative of him being like, I don't know if we can here.
yeah.
yeah.
Yeah, exactly.
The only
Let's-
thing, yeah, if it's
while we
getting
can, let's do it.
more and more. Like, see, this looks like a nice bed.
Fair enough. Because there's a shrimp. Alright. Are we doing Niskins first? Does anyone need, did anybody say if they need?
Well,
Fuck it, we'll just get two.
Just fire off two.
get two now.
Before you land.
Just before we
please.
touch down, yeah.
Yeah. 2 secs.
Oh, yeah, quit swearing on Mike, Jesus. Terrible.
All right, so we are, before we touch down and disturb the sediment, we're taking 2 water samples. Yeah, we're gonna correlate that with some of our sediment samples as well. And from the water samples, we can do biogeochemistry or look at the animals, things like that. Vamos a recolectar poco agua con botellas Niskin antes de recolectar sedimento. All right, Niskin number 1.
Okay.
And Niskin number 2. Those.
Looks good, huh? You feeling it?
Sure.
Where do we want to start?
Yeah, which ones do you want to start with? The special ones or the ones on the rail?
Oh Lord, everybody's looking around for someone else to answer that question.
I mean, we can case. Oh no, we should deploy them first.
Orders on that.
We can all stop in that vessel move. We're going to stop here and do some push scores. Stop in here.
Okay, so
Just land it. We'll see.
yeah, I don't know. Do we have the geochem in there?
All the special ones are on our porch at the front.
Okay.
3, the blue 3, and all the rest of them I just believe are.
Regular cores.
Yeah.
Yeah, why don't just start with one side and I'll look at.
We'll do the ones out in the rail.
Yeah.
Because they're all just normal.
Yeah,
And then
do
we'll
those first, then I'll
assess.
get.
Yeah.
Go on.
Come out for your rail before we land. Maybe not like.
Remember that time a minute ago where he said just landed and figured it out?
Then.
I landed. Come back up, bro.
No, it's alright. Your rail out
Okay,
down
yeah.
already.
Port one.
Yeah.
All right, so we're the plan here for this dive is to take some samples at the base, like the mouth of the canyon, of sediment and water, and then also take some samples, sort of working our way up. So we're starting off with the base, but there is some question about whether the turbidity will increase as we go up the canyon, which, as you might be able to ascertain, is a little bit difficult for sampling. So we're getting samples while we can, and we'll see what it looks like as we go up.
If we want to do one tester, are we pretty convinced these are going to be good?
You need to knock off the whole focus.
I mean, I think we can.
Do you want to thrust down as they come down?
Yeah.
Ready?
I'm ready. Thrusting down, easy.
Right, going down.
All right, so if you can see here, a little bit of the stuff that's coming up, we have that brown layer on top, and then there's like kind of a dark layer towards the bottom that is kind of upwelling, and that's kind of a good sign for us.
Is that enough?
I
All
think
the way.
that's enough. We just want that slight lip of
Yeah.
I think maybe it's only the special cores that need this the lip of oxygen, but
Correct.
It's me coming off the thrust.
right, so that is core number 1 put down. But yeah, so that little sort of black sediment there, that's probably anoxic and sulfidic, you know, probably a little bit different, and so that's kind of exciting. For question in the chat, ahora en el cuarto no, wait, well, no tenemos muchos hispanohablantes, pero puedo tratar. Estamos recolectando muestras de sedimento con cilindros para buscar por microbios. Se llama Archaeas Asgard.
Special ones that we need.
Perfect.
8 through 11. Yeah.
Pushing up on that. Thrusting down with like some.
8 through 11 here.
Wait, oh, the special, okay.
Yeah.
Also, all the special cores we're pushing here?
Yep.
Okay, perfect.
Yeah.
Except, wait,
Right off the thrust.
no, not 10.
Not
That
10, okay.
Is that 10's a geochem?
So we'll do 10 at the next one?
Yeah, right. So
10 with the rest? Okay, perfect.
Is that
check that.
Switch sponge.
Make sure.
Well,
I mean, is that what he's all about?
core 2?
So these
Mhm.
are site 1,
Okay.
and then these, sorry, are site
So
2.
don't we want to do that at the other site?
If that works for you.
I don't know where Jacob wants that after. So
He wants what all together?
8 through 11. So 3.
No, he didn't say that. He said 8 and 11.
Yeah, I mean, this should be at the same site though.
8 through 11?
Mm-hmm.
Okay, we're getting a second.
So we're doing both geochems at this first site.
Yeah.
Sweet.
Okay.
Happy?
Ready?
No.
Sit down easy.
And Jacob's reiterating, please don't core past the end of the 18.
Okay, sweet, yeah.
Easy.
Yeah. No.
Off.
All right, that's number 3.
And they said ideally close together.
Okay.
As well for those 8 through 11.
Perfect, perfect. We'll make sure to cluster. It looks like there's a lot of open space here, so I feel like shouldn't be too bad.
Ready?
Ready? Sit down easy.
Yeah, that's what I see. You don't do 10 here. Just do 9. Just 8 through 11, but not 10.
8 through 11, but not 10?
Yeah.
Okay, okay.
Yeah.
All right, that's number 4. Excellent.
Okay.
It's number 5. All right, and then from the porch, we're going to do, I guess we're also doing 6 and 7, so we'll do 6, 7, 8, and then we're going to do 9 and 11, but not 10.
Okay.
So the first 3, and then the back corners, and then the requests for 8, 9, and 11 are just close to the rest, within the general sphere of these, so we can correlate them.
And these are the last ones at this site?
Yeah, so we'll do 6, 7, 8, 9, 11, and then we'll go up the canyon for the rest.
You happy there, Mike?
Yeah, try it.
Bueno, muchas gracias por los saludos. No sé si será Mauricio por ahí. Estamos acá en la sala del ROP, en el laboratorio procesando muestras a la vez. Estamos en la punta del cañón La Paloma, en la estación 11. Cargada la muestra de la columna de agua con bastante zooplancton. Los primeros metros de la columna de agua, bastante zooplancton. Y bueno, dando lo último.
That's number 6, by the way.
Gracias a todos por sus saludos. Saludos a todos los que nos escuchan desde varias partes, desde las Islas Canarias, desde Uruguay. Gracias a todos por estar al pendientes y sintonizarnos en esta expedición en búsqueda de Asgard Archaeas. Estamos en este sitio de muestreo a casi 800 metros de profundidad y procediendo a procesar estos.
Okay. All right, so we are doing the entire porch here as well. So we were going to do 9, 10, and 11 as well.
Hubo una comunicación aquí para saber qué cores íbamos a muestrear. Y bueno, vamos a hacer todos los cores del 1 al 11. Les recordamos que tratamos de contestar sus preguntas en inglés, en español. Ian y Daniel están dando instrucciones para poder realizar este muestreo. Y poder tener las muestras que queremos de una forma pues más o menos cercana en el sedimento.
All right, so we're really excited about this this darker layer in the sediment here. All right, that's number 8. Because it's very likely nice and sulfitic, which is really great if you're looking for lots of different diverse microbes. But if you are stuck in a very small cold room and you don't like the smell of rotten eggs on a rocking boat, it can be a little tough. So, you know, shout out to many of our core processors for dealing with some of the intense, smelly, sticky muds, but it's all part of the job and kind of fun. I think for the tape ones, we want like a centimeter or so of lip of water on top. So maybe not like not 100% of the way in, but like 90%.
Do you want to pull in that reel? Yep. Because it'll give us a bit more space to do these 3 in.
Aquí los pilotos Mike y Tyler están muy concentrados para poder obtener estos scores y los queremos lo más cercano posible. Les recordamos a todos que pueden hacernos preguntas, trataremos de contestarlas.
Come on.
Is it live?
Yeah. Is the mic over here live? Back here?
Yeah.
Okay, about there, or
Gotta get in there.
I think that's probably, yeah, just about right. We're definitely capturing
Professor
the
Alison Santoro acaba de,
that should be perfect.
se acaba de unir a Misión Control y nos va a decir unas palabras. Alison.
All right, you're good.
Ciao.
Was that not?
Yep.
Yeah.
Allison, why is there so much snow here?
Well, higher up, a lot of the particles are sinking from the surface. But here in these canyons, there's also a lot of transport along the bottom of the ocean, and these really turbid layers that are dense, making it hard for us to see. They're called nepheloid layers. It's kind of like a underwater river of sediment, and they're extra thick in these canyons where there's a lot of sediment that's running off from the steep slopes. But there's something that are really difficult to study when you are only taking water samples or doing imaging with optical sensors. But to be able to see one with this kind of camera capability is really amazing.
Alison, what can you tell us about what you've been seeing at the surface?
Yeah, so just to introduce myself, my name's Alison Santoro. I'm a microbial oceanographer at University of California, Santa Barbara. And on this expedition, I've mostly been studying the water column. So a lot of the phytoplankton and other things that live in the shallow waters that sink down to these depths that we can see once they die. So we've been seeing a lot of variability in this cruise, which is really amazing. There's lots of different environments due to the different currents that are flowing around in this region. Also, we've had some weather, which mixes up the water column and creates variable conditions in the surface ocean. At this station, we saw that the light that's good for phytoplankton or photosynthesis was penetrating to a depth of about 100, 120 meters. We saw lots of cyanobacteria in the sunlit part of the water column. Also some smaller phytoplankton, smaller eukaryotic phytoplankton called big thrust of this cruise is trying to find Asgard Archaea in the sediments, but we're also looking for Archaea that live in the water column as well.
That's probably perfect right there.
Thank you so much, Alison. Now in the room is also Danilo, that he's been working on also in surface waters. What do you want to say some words, Danilo? Muchas gracias. Aquí está Danilo. Nos hace el placer de visitarnos en Mission Control porque siempre está muy ocupado en el deck. Danilo, gracias por estar aquí.
Hola, buen día a todos. Por favor, es un placer poder dar una vueltita por acá. Estamos en una estación que creo que todos estamos muy contentos, parece muy especial en el quiebre de la plataforma, aproximadamente poco menos de 1000 metros. Estamos viendo procesos en actividad a altas tasas, aparentemente, por lo que veíamos en la columna de agua. Ya de por sí el color del agua es quizás inesperadamente intenso verde para la profundidad y distancia de la costa en la que nos encontramos. Y bueno, lo que vemos con los sensores en la columna de agua por ahora parece confirmar eso. Y lo que estamos viendo ahora en el fondo también, tipo de sedimentos, cantidad de material particulado, cantidad de vida en general. Interesantemente, en la superficie, desde el puente, se está visualizando en este momento también una cantidad bien interesante de animales macro, mamíferos marinos y otros tipos de peces que en conjunto todo esto da una indicación de que este lugar parece ser bastante especial e interesante. Esperamos con ansiedad los resultados de los análisis que se van a hacer en las muestras, a ver si nos confirman o indican alguna otra cosa. Gracias a todos por seguir y por el interés.
Muchas gracias, Danilo. Gracias por visitarnos, darte un tiempo después de estar analizando muestras desde muy temprano en la mañana. Y gracias por visitarnos aquí. Juan nos va a contar un poquito acerca de los experimentos de datación.
Bueno, yo estoy colaborando con Daniel un poco, en verdad. Básicamente él está a cargo de los experimentos de producción primaria y respiración que estamos realizando a bordo del barco. Y yo trabajo luego con los resultados, vinculando lo que es la metagenómica y los procesos de producción primaria y respiración. Tenemos modelos desarrollados para nuestro observatorio microbiológico a 2 millas de la costa, y bueno, con este set de datos la idea es alimentar los modelos y entrenarlos nuevamente con nuevos set de datos, y la idea es, a partir de algoritmos de machine learning, poder predecir los procesos. Bueno, acá tendremos una caracterización básicamente en las distintas estaciones, porque para poder desarrollar esos modelos precisamos una gran cantidad de datos del mismo lugar, del sitio de muestreo, y acá estamos haciendo como una representación. Y bueno, lo que le quería comentar también es, bueno, en qué se basan los experimentos. Son mediante la técnica de Winkler, la cuantificación de oxígeno generado o consumido en un ciclo de 24 horas. Estamos haciendo incubaciones a la temperatura del agua donde se toma la muestra, y consta de botellas claras y botellas oscuras, un set inicial, y bueno, en las botellas oscuras solo ocurre la respiración de los microorganismos, el pequeño plancton, microplancton, y en las botellas claras ocurre el proceso de producción primaria y respiración en simultáneo, por lo que se pueden obtener mediante la misma técnica tasas de respiración y de producción primaria.
For chat, Juan, Zanetti.
Here.
Mientras Juan nos estaba explicando sus experimentos, aquí estamos teniendo una conversación acerca del tipo de sedimento. Está siendo un poco complicado obtener el sedimento, el push core completo, porque es muy suave y se está saliendo. Entonces,
Major shout out in the chat. I actually was able to identify the gadiform related to cod. Wow, my ego is. I think I know at least one fish in the ocean.
así es, seguimos en las costas de Uruguay. Estaba Danilo y Juan. También habló un poquito Alison Santoro, y mi nombre es Valerie de Anda, de la Universidad de Viena.
I mean, it could be the push core itself. There's a chance that it could not be.
Yeah, we can try the other ones because that one has holes.
Oh, this doesn't have holes, it's Jacob's.
But it has it doesn't have any
No,
holes?
it's just tape on the inside.
Okay.
But it could be easily could be the core.
It's just fluff.
It's just fluff, yeah.
It could be, yeah. We'll try the other ones, but it could be just the top of the core is not bent in properly.
Yeah.
Allow it to suck up. Or a few things that could come out there. We'll try the rest.
I can't hear you.
I watch it all the way back here.
We're not sure yet. That's why they're gonna try some more. Yeah.
Vamos a probar con otro push core a ver si tenemos otra suerte. Aquí tenemos a nuestro amigo el pez que está curioso, el muestreo. Y bueno, como pueden ver, todas las partículas que comentaba Alison, que comentaba Danilo, lo que están viendo en la superficie, bastante producción. También lo estamos viendo a casi 800 metros de profundidad. Yeah, that one looks good. Oh no, oh no, oh no. No queremos perder ese sedimento, así que estamos manteniendo la respiración aquí en Mission Control. Esos sedimentos se ven mejor.
Beautiful. All right, that was push core number 10 recovered.
Juan, ¿nos podrías explicar un poquito acerca de las corrientes, la influencia que tienen y bueno, el clima que también nos afectó y lo que estamos viendo aquí, las dificultades que hemos tenido durante las expediciones con el clima? ¿Nos podrías explicar un poquito acerca de estas corrientes en esta zona en Uruguay?
Bueno, justamente me levanté con esa pregunta, a ver si había influido las tormentas que habíamos tenido, habían traído masas de agua más frías. Uruguay se caracteriza por ser un lugar de convergencia de corrientes, lo que es la corriente de Malvinas, que es fría y baja en salinidad. Si bien acá estamos a casi 800 metros de profundidad, tenemos una temperatura de 4 grados y medio, se siente fría en las muestras. Y tenemos después la corriente de Brasil, que es más cálida y más salada. Y estuvimos en la corriente de Brasil cuando estuvimos cerca del Paleocanal. Era un agua en superficie arriba de los 20 grados, 22, 21, 22. Y bueno, esto hace que Uruguay sea una zona altamente productiva, rica en nutrientes y bueno, ese choque de masas genera alta productividad y bueno, es un poco lo que estamos evaluando mediante los experimentos de producción primaria. Y bueno, y después la plataforma también es una zona rica y se ha observado también cuando pasamos de una zona profunda a una estación costera, como al atravesar el talud y entrar en plataforma empieza a aparecer otra fauna, los petreles, los albatros, bueno, ballenas, como también como según la topografía y en qué parte del mar y el territorio marítimo uruguayo estemos, es la biodiversidad que se encuentra presente. Esta campaña también se está generando un montón de información que va a quedar disponible para toda la sociedad, para instituciones y bueno, realmente es un gran avance para la ciencia en el Uruguay y bueno, y para la planificación espacial marina que está tomando fuerza en el país.
Y bueno, también el público, ayer tuvimos un Ship to Shore en La Paloma, Juan, y fue muy bonito ver el entusiasmo de los niños, las preguntas que hacían, incluso había niños que era la primera vez que venían y veían el mar, ¿no? Por primera vez y las preguntas fueron bastante emotivas, ¿no? Así Ceci y yo nos vimos y queríamos llorar de que las preguntas eran bastante emotivas. Entonces sí, también el generar conciencia, el tener ese contacto con el mar y protegerlo y cuidarlo y conocerlo mejor.
Sí, sin duda. Una de las preguntas que nos hacían era cómo podían hacer para conservar igualmente, aunque estuvieran en una zona rural o lejos de la costa. Y bueno, y la respuesta nos dejó bastante, o sea, la pregunta nos dejó bastante como, bueno, sorprendidos, aparte de viniendo un niño y bueno, ya con esa preocupación. No hay que... las nuevas generaciones a veces cargan con ecoculpa por cosas, pero bueno, ellos ya tienen otra conciencia de lo que es el ambiente y la responsabilidad del ser humano en los ecosistemas. Y bueno, y solo con estar interiorizándose en los temas, aprendiendo y bueno, interactuando y participando ya.
Y sobre todo porque eran preguntas que él venía representando a varios niños de su escuela, ¿no? Y eran las preguntas que más se hacían, ¿no? Cómo acercarse, cómo conservar, cómo cuidarlos, cómo cuidar nuestro planeta, el océano. Entonces sí, esa parte también es muy importante, dar a conocer lo que existe. Por eso estos live streams también son, pues es una forma de acercarnos, de dar a conocer lo que existe en nuestros mares y conservarlos y protegerlos.
Sí, también tuvimos una pregunta muy interesante que fue acerca de la contaminación lumínica. Nosotros estamos estudiando muchos procesos que vinculan la luz. Incluso, bueno, también nuestro laboratorio básicamente es a oscuras porque trabajamos con materia orgánica y la materia orgánica puede sufrir modificaciones o alteraciones por la luz. Pero la pregunta y la inquietud venía por la contaminación lumínica y la pérdida del cielo nocturno. Y bueno, también eran inquietudes que bueno, surgen de los intercambios en los ship to shore o en los streaming, incluso en el chat. Así que queda abierto a cualquier consulta o pregunta que quieran hacer.
No. Estos sedimentos están siendo complicados.
One more time with this one and then we'll just leave it. Or...
Thank you, Mike.
Please, yeah. It's probably move.
Sí, estamos teniendo estas dificultades para poder tener el sedimento.
Give it a shot. Shake it a lot beforehand, you know. Nice.
I think the closer we are to the black patch, the better. The more compacted the sediments are going to be. So like those that are in that black area are going to be easier to get them. Thank you so much, Mike.
Sweet. That's 7 recovered.
Got it eventually.
Keeps things interesting. En el chat ahora tenemos pilotos Tyler and Mike.
Que están haciendo un trabajo increíble con mucha paciencia para poder recuperar estos sedimentos tan preciados. Y bueno, aquí exactamente aguantando un poco la respiración.
Tyler and Mike. right, that's number 6. Actually, hold on.
Buenos días a
Is
todos.
there any chance that we could try number 11 again, but shake it a whole bunch beforehand and shove it in as far as possible?
Yeah, that's kind of difficult now because the rest of them are in.
Oh, okay, okay. No worries if
We've
not.
got less margin for error. I can easily try it if you want.
Okay.
One more time.
It might be. We got a request for that.
I think if we try like put it in the black area, Mike, it will be easier, but there's no more space left in that.
We intentionally put it in the hardest.
Yeah.
one.
Yeah.
It's gonna be.
No.
Here? Oh, man.
No. No.
I should have asked right before we did 6. Relaying.
Try and get a nice little
If it's like hilariously hard, absolutely no worries. But that's not a challenge.
It's always a challenge. These guys are still stuck on there now.
Yeah, that's what we should have done.
I think this
Yeah,
one's
just leave it for
actually-
sure. Yeah, that's definitely jammed. No
Yeah,
reason
I don't know.
to tear it off the board. All good.
Sorry.
No, you're right.
I don't know someone's up with that.
Estamos en las costas de Uruguay, en el talud a unos 800 metros de profundidad, aguantando un poco la respiración para obtener estos sedimentos. Esos cores se ven mejor. Aquí está el mapa. Gracias, Alex. Nos muestra la ubicación de donde estamos. También les recordamos que nos pueden seguir. Live tracker en SOI en búsqueda de Asgard Archaeas.
Gorgeous. That's a good one. Number 5.
Score 5. Se veía bastante bien. Uy.
Try it again?
Yeah.
Let's give it one more shot, I suppose. This is where they're all going to be. All the hots.
Yeah, I think it's gonna be a good site. It sucks it's so hard.
Yeah. Right over here, now bit.
Yeah.
Do you want me to clear this pigment a little bit more?
Yeah, I suppose a little, but
Much as we can.
Yeah, as much as you can. Thank you, Mike.
Good.
Yeah.
Yeah.
oh yeah.
Clear that half as a little bit. Try and get this back one back then I'll be able to see it.
This doesn't help.
Seals. Put that light back on.
Acaba de entrar a Mission Control Professor Galen para ver un poquito lo que estaba pasando aquí con el muestreo, con los sedimentos. Y bueno, les recordamos que pueden hacer preguntas acerca de la expedición, acerca de curiosidades que tengan.
Insane sedimentation here. I think there's probably like, since we landed, there's probably an inch more of sediment.
Here, these push cores might be not the most interesting, has obviously never felt the sheer anxiety of just sitting in mission control during the process.
Yeah, we're gonna get these in and we'll go. Let's go up there and then we'll go to the right. Go up top of it.
Yep.
Oh yeah, the other side, it's a core, so whenever we.
That's something else, huh?
We'll have time to go all the way up there before we.
Wow.
Go up. Oh crap.
Yeah.
What happened?
Bueno, el Dr. Galen, que es experto en geología, nos puede comentar un poco acerca de estos sedimentos, lo que estamos viendo, la poca visibilidad, la alta tasa de sedimentación. Estamos viendo mucha materia orgánica siendo depositada en el fondo durante esta transmisión. So, yeah, welcome, Galen. What can you tell us about this site?
Probably not too much just yet, but I mean, it looks we're in a channel, and I guess it's we're in a submarine channel, and it looks like it's still a very active channel. So these submarine channels are conduits for sediments that are traversing from the shelf down into the deep ocean. And so probably that's part of the reason we're seeing so much sedimentation, is that they are channeling down through here. And what I wasn't sure before we visited the site is whether or not the channel was still active or not, but it seems to be very active. Very active. It's probably after it was very active during the last glacial maximum when sea level was about 120 meters lower, and the rivers were delivering sediments all the way to the edge of the continental shelf and dumping them off the edge. But then after sea level rose, starting around 20,000 years ago, it would have flooded the whole shelf, and the sediments would have been trapped up on the shelf for a long time, and probably not. These canyons probably became quite inactive, so I guess maybe some of the underlying sediments is finer grained from when the sands weren't traveling down through the channels, but now it appears that they're pretty active again.
Yeah. Mike está prácticamente a ciegas haciendo este trabajo con el submarino.
EC3.
Thank
Yeah.
you.
Wow.
Thank you, Mike.
Finally on the course.
Good enough.
Yes, it's all relative.
As soon as we get all that. Yeah.
That's not too
Even
bad.
in the bottom.
So that just floated by, for those of you who are interested, is a pyrosome. So it's like a funky little pelagic fella that must have gotten swept up a little bit in the current. But they're photosynthetic, but presumably probably also filter feed. So they might be really stoked about about all the particles in the water. Who knows?
Just to make sure I'm not doing something stupid.
Estamos tratando un poco de aguantar la respiración aquí porque la visibilidad es muy poca y está siendo bastante difícil este muestreo, pero nuestros pilotos Mike y Tyler están haciendo un trabajo increíble y estamos muy agradecidos por por la paciencia que tienen para obtener estas muestras.
I think we lost it. Oh, brutal.
Nothing in that one.
Yeah, just put it in though. We can't work in
Yeah,
these
this is
conditions.
it's brutal.
Zoom in right in on that.
If we can get it in.
Chuck it in the rock box here.
Yeah, no, we could do that. So I've got more chance of getting the blue one in. This one at the back being like grey.
Yeah, if it's empty, wherever you can put it, yeah.
Right, yeah, let's do that. Alright, I don't think. Unless.
Wait, which one is this one?
This is 2.
This is number 2?
Yeah, absolutely.
So, number 2 is empty. And number 11, right?
Yep, 2 and 11 are the 2.
Why is it all? No, rather than.
Estamos muy callados aquí aguantamos un poco la respiración para no molestar y desconcentrar a los pilotos. Se está perdiendo el sedimento otra vez.
Try it again while we see
No,
what
I
that
think
is.
it's okay.
Yeah, I think we can. I think we'll maybe be able to get the one.
Yeah.
Let's see if we might be lazy. Fan round and see if we can see a suitable spot there. Stick this thing further. Yeah. It's up to the good spot, I think, isn't it?
Go eat quick and I'll be back from the cruise.
I don't think this one's good.
Yep.
Just leave it.
What are your thoughts, Val?
Yeah, I think leave it. It's fine. We can try the other. We're gonna go to another side.
Yep.
So
Alright.
we can just leave it. That's number 1 and 11. The ones that we
1,
couldn't
2,
get.
11, yeah.
Okay.
We
So
got
the one empty is 1.
1, 2, and 11 are empty.
and 2.
One.
11's stuck.
1, 2, 11.
Oh,
And
1
11
and
is stuck.
2.
Sorry,
Okay.
yeah,
Okay.
yeah.
I
No, you're-
thought, yeah.
No, not
1,
1,
yeah,
2,
1,
1
2.
and
Yeah.
2.
It was a little bit. Okay, 1, 2, and 11. Yeah, we can try the other side
Oh, yeah.
and try to get those 3 together. Maybe
Yeah, 11
one
is stuck. Like, they can't get it out.
11's stuck.
stuck in where?
Yeah,
In
that
the
looks-
core sleeve.
Oh
it looks a
shoot.
bit, something doesn't look right with it. So
Oh yeah, since the beginning it was kind of weird, right?
Mm-hmm.
Okay.
But 1 and 2 should be.
Yeah. Okay. Yeah, we can just go ahead and
Yeah, we
head
can
to the
waypoint
other.
them. One and two are basically, you can just try them again if you want. One we're at a different spot.
Yeah, yeah.
11 might be.
It might be difficult
start
to.
of the end.
Yeah. Está no bien. Huge fan community and in the chat, and shout out to Mike and Tyler. Thank you guys.
Thank you.
It was
Expert.
Mike wanted his push course.
so yeah. Now we're heading
Some of my eyesight.
to the to the other side.
Yeah, hopefully it's a little bit clearer, but the sediment is probably coming from up the canyon, so who's to say? We're gonna find out.
Yeah, it's kind of surprising the high sedimentation rate that we see here.
It's crazy how
It's crazy.
things came in.
Yeah,
The
yeah,
pulses.
yeah. Did we get any Niskin bottles in
Yeah,
here?
we fired off 1 and 2.
1 and 2. Okay. It's gonna be full of OM.
So. Yeah.
Saludos a todos los que nos acaban de sintonizar. Les recordamos que estamos en las costas de Uruguay. Ahora vamos a dirigirnos a otro sitio de muestreo. Todavía no subimos. Estamos todavía pendientes de recolectar más sedimento y bueno, esperemos que esos sedimentos sean un poco más fáciles.
Bridge ROV. Go ahead. Yeah, we're gonna start moving off again, mate.
Starting tomorrow again.
Thank you. BBLs, yeah, okay. Yeah.
It has blood on it, actually.
I'm off now.
I had to stop it from taking off. Hayden's nose. I'm gonna do some quick maneuvers to try to clear it. It's giving me more trouble.
Evasive actions.
Basic maneuvers.
This is crazy.
Hay muy poca visibilidad aquí. Vamos a ver si mejora para que veamos un poco más de
Yeah.
la diversidad de las costas uruguayas. Les recordamos que pueden seguirnos en el link de SOI, que pueden ver dónde nos encontramos. Ahora Tyler nos está llevando al otro sitio y vamos a ver si la visibilidad mejora un poco. Y mandamos muchos saludos a todos los que nos están sintonizando.
Yeah.
pretty soupy.
This is unreal. Yeah.
Reminds me of I went lobster diving once a couple years ago. And it was so murky that I just smacked my face straight into the sand.
Just like,
Yeah, literally.
Oh man. You got a lobster though.
Actually, on 2 separate occasions, it was so surgy that I stuck my hand down to grab the reef, and I had a lobster in my hand. Same dive twice. Just tried to grab the reef, and it came away, and it was a lobster.
It's alive.
Crazy.
Wow, that's nuts.
Kind of a good question in the chat right now. Someone asked, what do they do, like, if there's a rock? Would we see the rock? And right now we do have our forward-facing sonar on. So this is on the ROV. We've got kind of an interesting artifact in how it's presented up on your screen right now, but you can make out that sonar there. What would a rock look like?
solid.
Something solid on there?
A lighter target.
A lighter target is what Mike says.
Yeah, we're at 6 meters, so please enjoy the shrimp.
Nothing better than shrimp.
Not bad.
That's very important, especially for when you're, you know, in places where there's hydrothermal vents and like high columns of dozens of meters, and you don't want to hit or stamp against a black smoker. So yeah, it's always depending on what you could find down there. We have a mapping of the place that we're heading to, so we have an idea previously of how the bottom of the ocean looked like.
Yeah. That's 3.5 minutes off. Never back in it, huh?
Wow.
2.5 meters. Yeah.
Goodness.
Wow. Definitely somewhere we're gonna reach. It doesn't look like this.
How fast are we going? Is there like a...
We're going like 2 meters.
Okay, it's on. Sweet. It's like speed over soup, really.
Yeah.
Speed through soup.
Speed through soup.
Sí, la visibilidad está claramente afectada por esta gran cantidad de materia orgánica que está cayendo en este canal a casi 800 metros de profundidad. Y aquí en el live stream está una experta de Cure, de Uruguay, Cristina Bañobre, y ella estamos preparando los sedimentos para que ella pueda procesarlos centímetro por centímetro y nos pueda decir qué tan recientes son estos sedimentos. Hasta 100, 150 años. Y bueno, yo creo que aquí en estos sedimentos se ven muy recientes, se están formando, se están depositando toda la materia orgánica que está cayendo en estos sedimentos, pero bueno, estaremos muy pendientes de sus análisis para ver y comparar todos los sitios que hemos muestreado, todos los sedimentos que hemos obtenido, cuáles son los más antiguos. Ahora estamos a 800 metros Hemos estado a 2000 metros de profundidad. Y bueno, le mandamos un saludo muy grande a Cristi, que está al pendiente de estas transmisiones. También van a caracterizar la cantidad de materia orgánica y contaminantes en estos sedimentos. Entonces vamos a tener una comprensión bastante clara de lo que está pasando en todas estas áreas. Así que estaremos pendientes. Aquí vemos otro pez. Pero bueno, el experto en peces es Ian. Ian, what kind of fish was that?
I'm not an expert in fish.
Well, some taxonomic ranks, that's an expert for us microbiologists.
But yeah, we're working our way up the canyon. We'll see what kind of sediment we're looking at towards the top, but you know, I don't want to jinx it.
Yeah.
By mentioning the visibility here, so I'm not going to go that far, but
Improving.
yeah, you said it. Yeah, it's always amazing. Like, if you followed some of our streams previously, we had one other dive through a canyon, and it was not nearly this bad, even though it was only like probably 50 nautical miles away or something like that. So each canyon is so far had its own personality.
Yeah, we had another dive, but it was very hard to see and visibility was really bad, and just also was amazing and get all those scores practically like zero visibility, so that was pretty amazing too. Y bueno, también acaba de entrar Emily Hyde, estudiante de doctorado de la Universidad de Austin, que ha estado trabajando en medir la concentración de oxígeno en estos sedimentos, trabajar con las muestras de agua, filtrarlas, y ha sido también un trabajo arduo, no han parado de trabajar. Así que le voy a dar el micrófono a Emily. What can you tell us about the water filtration, like the issues that you've been having, and just kind of related to what we're seeing in terms of all the organic matter and the high productivity that we are seeing in the screen?
Yeah, so here where on the screen you're able to see how much organic matter is in the water column. So while this is a very productive area, this is actually fairly hard to filter because what we're interested in is the microorganisms that might be attached to some of this particulate matter but are much smaller than the eye can see in this stream right here. So for different areas of the water column so far that we've been filtering, there's some areas that we are having to filter liters and liters of water just to get enough microbial DNA in order to sequence it on board. And then in other areas, we might be only able to filter like 1 liter. It's probably similar to this area. There's so much organic matter here that it basically fills up our filters before we're able to get enough of our, it basically fills up our filters very fast, and so we can get DNA off of it pretty quick. So really just depends on the area. So it's really nice for us to have a stream of the water column on the ROV so that we can, you know, have an idea of what the filtering is going to look like when we're actually filtering it back on board. Because just a reminder, we do have 6 Niskin bottles on the ROV, and so at different locations we can fire off these Niskins and take water. We basically have a snapshot of what the water looks like at certain areas, and so we're actually able to have an idea, just a prediction of like how difficult is this water going to be for us to filter through it to be able to get enough microbial DNA, because we basically want to get rid of all of this organic matter to be able to find the microbes that are hiding in this water column.
Thank you so much, Emily. That was a very thorough explanation.
There's something wrong with it. Well, it didn't suck up anyway. It didn't.
Y bueno, estamos haciendo un cambio de pilotos, tomando. Y bueno, Alison Santoro, it's also here.
Hey everyone, this is Alison Santoro again from University of California, Santa Barbara. I just wanted to say a special hello to my little nieces, Cara and Ellie, that are watching from the east coast of the U.S., and also to all the kids that are watching. Someday you could be out here with us.
Y bueno, también mandamos saludos a México, mi familia, que me están escuchando ahora. Les mando muchos saludos. Y bueno, ahora estamos haciendo un cambio de pilotos. Es el siguiente turno para que llega Chris y Jess.
So the rest of these are all good. These front two beats on about the time we wait in order is we can do these two again. This is the way. But you probably won't be stopping too much.
Y bueno, les recordamos que también nos pueden seguir en nuestras redes sociales. Estamos tratando de capturar el día a día de nuestro trabajo, de filtrar agua, extraer DNA, analizar los datos, también con los sedimentos, un poco del día a día a bordo de esta magnífica expedición, las instalaciones, todo ha sido una experiencia bastante enriquecedora. Y bueno, aquí en el chat reconocen a Emily, Water Micro Girl, en social media. A mí me pueden seguir también, Valdeanda. Estamos tratando de mostrarles un poco acerca del trabajo que hacemos, un poco de nuestro día a día. Y bueno, también pueden preguntarnos acerca de experiencias académicas, preguntas que tengan acerca de doctorados. Tratamos de responder las preguntas que tengan. Y bueno, si están interesados en ciencias, si están interesados en exploración del océano, lugares extremos, exploración, entendimiento de nuestro océano, hay muchas redes sociales que pueden seguir para seguir un poco el camino de exploración y descubrimiento. Schmidt Oceanographic Institution, por supuesto.
Just following roughly the hills kind of start turning on you, Jess. So we're looking more back towards the boat, but we're trying to come up the canyon. So we've got to do a best of both worlds, follow the hill along the line.
I'm always happy when we always hear this run. Jesus, world movie?
Yeah, so I went to go check real quick.
So what have we been seeing this time?
Well, shrimp and fish.
Rains now.
Some snow? Good.
A lot of snow.
Sure. It's almost the winter effect.
That's what I was saying. So came here to escape the snow, and didn't help much.
Saying you brought the weather.
Sounds about right. So our calmest day on the surface is not far. Nasty. Down below. canyon, yeah, sort of trying to see if there's anything interesting differences in sediments as we head up. But so far, pretty homogeneous.
All better for seeing you. That's a Jew.
Big chocolate.
That's true.
I think for this,
This is so on it.
I know, right? No, I think at the moment I mean, doesn't matter too much of it, but sometimes it's nice to have the sense of scale.
I don't know if you saw me this out.
Very hot in there. I'm so glad I put shorts next week.
How's it, Tyler? It's cold. 1 minute. More time to smoke.
Is this the new sauna that they've been talking about? Is that the new sauna? Yeah. We'll complain about the heat, but what do you want?
Yes. So much better. Oh. Yeah, we're gonna train for a little championship.
I'd be pretty stoked. I mean, they're just sitting there.
Or you swap it for me?
Okay, sweet. Awesome. Yeah, well, I'm heading out. Gonna eat some delicious lunch, but hopefully y'all enjoy the rest of the stream. I think Val is tagging in for me on watch. Yeah, hopefully you find a bunch of cool stuff and enjoy. Hopefully there's clear water and nice, beautiful cores up ahead. Cheers. See you.
Yep. Daniel, welcome.
Hola a todos. Estamos aquí cambiando watch leads. Ahora me toca estar con Galen. Para ver este segundo sitio de muestreo. Se ve un poco que la visibilidad va mejorando. Aquí contentos de estar con Jess y con Chris. Jess me contaba que tiene un doctorado en materiales. Es buenísima. Me ayudó a imprimir un push core slicer, una 3D printer. Y toda su ayuda y toda su pasión y su trabajo se ve reflejados y todos estamos muy contentos. Estamos a casi 800 metros, subiendo un poco ya a 730 metros. Ya realizamos el primer muestreo y ahora vamos en búsqueda de un sitio donde podamos tener más sedimento. Gracias a todos los que nos siguen sintonizando, siguen viendo estas transmisiones. Les recordamos que esta es la expedición en búsqueda de nuestros ancestros, las Asgard Archaeas. Y como les comentábamos, han sido días muy arduos. Cada equipo de trabajo está realizando diferentes análisis con estos sedimentos, con las muestras de agua. Y les recordaba que también aquí veo en el chat hay especialistas de invertebrados marinos. Sin embargo, esta expedición está enfocada en microorganismos y aunque no los podemos ver a simple vista, sabemos que están ahí, sabemos que existen y es un poco también parte de esta expedición, el dar a conocer la importancia de estos microorganismos que aunque no sean formas de vida que podamos ver a simple vista, fueron los responsables, los ancestros de estos microorganismos fueron responsables de dar lugar a toda la complejidad celular, toda la complejidad que vemos, toda la vida marina que vemos. Incluso nosotros, los seres humanos, las Asgard Archaeas fueron responsables de dar lugar a este evento evolutivo tan importante en la historia de la vida de nuestro planeta. La aparición de la célula eucarionte en el registro fósil, o bueno, de los primeros fósiles que aparecieron, que se tiene registro, data de alrededor de unos 2.000 millones de años. Aquí tenemos al especialista en eucariontes de hace miles de millones de años, Professor Galen. Galen, what can you tell us about the importance of finding eukaryotic organisms or presence of these fossils in the sedimentary rock record?
Yeah, so the fossil record is really the only way we can get at the early history of eukaryotes, particularly before the last eukaryotic common ancestor. And by finding these fossils, we can this is work I'm doing with some colleagues right now, we are beginning to pinpoint the sort of environments or habitats in which these very earliest eukaryotes lived on Earth between maybe about 2 billion years ago and about 1.6 billion years ago.
Con respecto a estos sedimentos, hay algunos sitios a más profundidad con una actividad geotérmica más importante, donde minerales que vienen desde la corteza terrestre directamente se escupen hacia arriba como volcanes en las profundidades, ventilas hidrotermales o fumarolas negras, como existen en algunos sitios. Y en estas zonas el olor a huevo podrido, que es el ácido sulfúrico, es muy fuerte. Es un proceso de reducción de sulfato. Algunos microorganismos respiran el sulfato, lo utilizan como último donador de electrones y de esta forma ganan energía, y esto lo convierten en H2S, y este compuesto es el que da lugar al olor a huevo podrido. Estos microorganismos existen en condiciones anaeróbicas en estos sedimentos y también conviven con organismos formadores de metano o arqueas metanogénicas. Estos organismos utilizan compuestos de descomposición de materia orgánica y como producto de desecho producen metano. Todo este ciclo, estos ciclos biogeoquímicos, esta regulación tan digamos, orquestada, se está llevando a cabo en estos momentos, en estos sedimentos, incluso aunque no lo podamos ver, pero sí en algunos sitios que hemos muestrado el olor a huevo podrido es bastante obvio. No es tanto como en algunas otras zonas donde he tenido la fortuna de caracterizar y de ir al fondo del mar en submarinos para obtener estas muestras, pero sí hay actividad de sulfato reducción y de metanogénesis en estos sedimentos. Seguimos avanzando. Aquí podemos ver en el mapa la ubicación donde estamos. Gracias, Ian, por mostrarnos dónde nos encontramos ahora con el ROV. Y bueno, vamos, como les mencionaba, a nuestro segundo sitio de muestreo. Galen, can you tell us a little bit about what we're seeing in the map, the location of where we are?
I can't, probably not much. It looks like the sediments are overall pretty sandy, probably a lot of fragments of shells, all the white, kind of salt and peppery looking. We're in a channel, so I suspect sediments get washed in episodically by sort of catastrophic events called turbidity currents, which travel down the slope and are a major way in which sediments are transported out into the deep, coarser grained sediments are transported out into the deep ocean. So I suspect that's what we're seeing here. And so these are probably include sediments that were up on the shelf at one point and have now dropped down onto the slope. So not as muddy as some of the other deeper water sections that we've sampled so far.
En el mapa donde nos encontrábamos simplemente fue un mapeo que se realizó para poder tener una idea de la superficie, de donde nos encontrábamos. tener una idea de qué tipo de canal íbamos a explorar. Les recordamos a todos que, bueno, cuando bajamos al fondo del mar, vamos prácticamente a ciegas, vamos prácticamente sin una idea de lo que podemos encontrar. Entonces es muy importante realizar un mapeo, sobre todo en sitios que no han sido explorados como estos. Es muy importante tener una idea de lo que vamos a ver allá abajo y a dónde, en función de eso, diseñar el mejor muestreo en función de las características que vemos. Aquí Chief Scientist Brett Baker está justamente tomando estas decisiones, habiendo analizado las características topográficas del fondo, de qué tipo de sedimentos podemos encontrar, y entonces en función de eso ya podemos llevar el submarino a estos sitios específicos. Entonces es un trabajo constante donde requiere la interpretación y el análisis de muchos datos y de instrumentos que podemos utilizar a bordo del Falkor para poder realizar todos estos muestreos de forma coordinada. Y bueno, yo no soy experta en mapeo, pero tengo colegas, mi amiga y colaboradora Carmen, que es experta en este análisis de datos e interpretar las características de los sitios donde muestramos. Por ejemplo, en sitios donde hay ventilas hidrotermales también es importante muestrear, tener una idea del fondo marino. Cuando tuve la oportunidad de estar en el Alvin y bajar a 2000 metros de profundidad y ver esto con mis propios ojos a través de la ventana del Alvin, en una expedición que hicimos Brett y yo a cargo de la doctora profesora Mandy Joy. Bueno, era muy importante tener una idea de estos, del sitio donde íbamos a ir a muestrear, sobre todo en sitios que son altamente dinámicos y cambian bastante. Y todo esto nos da pistas, nos da una idea de lo que está pasando en el fondo del mar, todos los procesos que ocurren, y tener un mejor entendimiento de este engranaje que permite sostener la dinámica química y las redes tróficas de nuestros océanos. En sitios donde hay sitios en nuestro planeta donde los océanos no hay tanta deposición de materia orgánica, no hay tantas nieve marina, como podemos ver aquí en pantalla. En esta zona de Uruguay sabemos que hay bastante deposición de materia orgánica que estamos viendo como va pasando en tiempo real, y nos habla mucho de los procesos y de la importancia del fondo marino, la importancia que tienen los microorganismos, que son los que al final se encargan de degradar toda esa materia orgánica y guardarla, guardar el carbono en nuestro planeta. Los sedimentos marinos son la fuente de carbono más grande que existe, lo guardan en forma de metano. Entonces son el reservorio más grande de carbono. lo cual les da una idea de la importancia mantener y preservar y entender los procesos que están pasando a nivel microscópico en nuestros océanos y qué pasaría si estos microorganismos dejan de existir. Pues básicamente la cadena trófica dejaría de existir, nosotros no podríamos existir, todos los ecosistemas se verían afectados, incluyendo el océano. Entonces, mientras más entendamos estos procesos que ocurren en el fondo, más entendimiento y más conciencia podemos generar para proteger nuestro planeta. What do you think, Galen?
About what? About the organic matter?
Yeah, the organic matter and like how important are the microbes that are basically degrading all of this and
well,
they're
very important because most of the organic matter will be degraded before it gets buried very deep in the sediment. So it's amazing, all this rain of particulate organic matter coming down. Obviously, that's a sign of a lot of nutrients, and that's why we're seeing so many fish and other animals in here. But a lot of organic matter is making it to the sediments, but almost all of that will be remineralized and turned back into CO2 before it gets buried very far. But in productive zones like this is where higher concentrations of organic matter manage to be preserved, and eventually then providing a source for the methane you were talking about. And if it gets buried deep enough, then of course it can make other hydrocarbons as well.
Yeah.
But what it suggests is that we should probably, the sediments will become anoxic very quickly with depth.
And that's why it's important, all the measurements we're taking, oxygen profiles, sulfate rates,
Yeah, exactly.
methane rates.
Yeah, so a lot of sulfate should be getting used in these sediments, I suspect.
There it is. Yep. The SOI.
Oh, yeah.
There.
Ahora estamos viendo unas imágenes de lo que está pasando arriba en la superficie. Entonces tenemos un visitante marino. Una foquita nos vino a saludar. Y bueno, la experta en avistamientos de mamíferos marinos, Lucía, nos estaba contando ayer de los avistamientos que ha hecho. Ha visto ballenas, delfines, muchas aves marinas también. De peces que estamos
Fish and more fish.
están enfocando a tener imágenes. Seguimos de camino a nuestro siguiente punto de muestreo. Como se podrán observar, estamos subiendo y bueno, ya estamos a casi, 700 metros de profundidad y vamos subiendo. Y estamos enfocados en tener muestras de sedimento con los push cores porque estamos haciendo análisis de datación, análisis de perfiles de oxígeno, estamos haciendo perfiles de tasas de perfiles biogeoquímicos, entonces necesitamos el sedimento, este perfil de varios centímetros, de 25 centímetros, para poder distinguir lo que pasa en la superficie versus lo que pasa más al fondo. Entonces es por eso que realizamos los muestreos con los push core. Vamos subiendo un poquito más hasta llegar a nuestro siguiente punto de muestreo. Y creo que sí, creo que pasaron por ahí varios camaroncitos rojos. Y bueno, les recordamos que cualquier duda o inquietud nos pueden consultar por medio del chat, seguir la expedición en la página de SOI, por redes sociales. Aquí vemos la foca que está en la superficie. El visitante. Bueno, por aquí preguntan que por qué no estamos viendo corales u otras formas de vida. Ahora estamos subiendo 683 metros de profundidad y recordarles que los arrecifes de coral se encuentran en aguas poco profundas, necesitan fotosíntesis. Y bueno, los corales formadores de arrecifes pueden crecer a profundidades inferiores de 30 metros y donde el rango de temperatura está entre 16 y 32 Celsius y donde tengamos altos niveles de luz. Aquí la temperatura es 4.79 grados centígrados. Bueno, aquí vemos un animalito en descomposición, probablemente sí. Está en proceso de descomposición. Bueno, toda esta materia orgánica es la que va a formar parte del sedimento. Un pececito muerto. La superficie sigue nuestra visitante. Es un pez bastante grande. Hay varios avistamientos en la superficie. Mientras nosotros estamos aquí en el submarino. Parte importante también de esta campaña es justo el tener un entendimiento de los procesos que llevan a cabo los microorganismos. Justo, mira, ahora tenemos otros visitantes. Estamos teniendo muchos visitantes en este sitio. Aves marinas, peces, focas, mucha diversidad. Y hablando de diversidad, hay movimientos actuales en donde científicos, incluyéndome a mí, estamos haciendo esfuerzos para poder apreciar y sobre todo de llevar el mensaje de la importancia que tienen los microorganismos en nuestro planeta. Y no nada más desde un punto evolutivo, como son las Asgard Archaeas, sino a nivel sostener todos los ecosistemas, incluyéndonos nosotros, los seres humanos. Tenemos alrededor de 1 kilogramo de nuestro peso es solo microorganismos. Y sabemos que hay más microorganismos en el planeta que estrellas en el universo observable, 1 por 10 a la 30. Número de microorganismos, el número de estrellas en el universo observable es 1 por 10 a la 21. Y tenemos también 1 por 10 a la 31 número de virus estimados en nuestro planeta. Entonces, si tomamos en cuenta que vivimos rodeados de microorganismos, llevan a cabo procesos fundamentales y sobre todo son los responsables de dar lugar a toda la vida compleja, como son los ancestros de las Asgard Archaeas. Si tomamos en cuenta la historia de la vida en nuestro planeta, la mayoría de la vida ha sido microbiana. No fue hasta la explosión del Ediacara Formation en el Cámbrico que se dio una explosión de vida.
Sí, la biota hace 575 mil millones de años comenzó. See, sorry, my Spanish didn't come out very well. About 575 million years ago, the first animals, macroscopic animals, appeared in the geological record. And so about 40 million years before the actual Cambrian explosion.
Yeah. And so if we think about 3,000 million years before that, life on Earth was microbial, basically, dominated by microbes that gave rise to all of the complex life that later appeared in the history of our planet.
And it seems, I mean, really even until about 650 million years ago, the biosphere was still dominated by microbes. Even though eukaryotes were there, it was really the mostly cyanobacteria that were driving the ecosystem up until that point.
Y bueno, aquí en esta expedición estamos un poco sesgados a buscar vidas microscópicas y fungi como tal también existen. Hay varios grupos de investigación que se dedican a caracterizar hongos, no como tal los conocemos en los bosques, pero sí hay organismos eucariontes con micelio y tal que incluso son muy importantes en la degradación de materia orgánica también en estos sedimentos. Depende de los sitios donde se muestre, pero sí hay bastantes grupos de investigación que se dedican a caracterizar estos y cultivar los hongos que existen en el fondo del mar. Tuve que pedir una barrita de proteína para comer algo, así que si escuchan esos sonidos es porque tuve que comer algo. Gracias, sí. No voy a descuidar mi alimentación. Ya me trajeron más comida. Muchas gracias. Thank you, Sandy. Se preocupan por mí, lo agradezco mucho, porque luego sí, uno descuida la alimentación a veces por estar en el trabajo, así que agradezco mucho a Emily y a Swati que están cuidando de mí. Y bueno, también quería comentarles un poco del trabajo que estamos haciendo con metagenómica en tiempo real. Fue trabajo que empezamos el año pasado a bordo del Atlantis. Realizamos secuenciación en tiempo real de sedimentos provenientes de ventilas hidrotermales que colectamos a bordo del submarino Alvin, y ahora implementando mucho más capacidad de tecnología, análisis de computación para poder dar una idea de las comunidades microbianas que están en estos sedimentos y en la columna de agua también. Y esto también fue parte de mi proyecto de National Geographic, y bueno, muy contenta de ser exploradora de National Geographic y formar parte de esta comunidad de exploradores y apasionados por conocer nuestro planeta. Aquí mandamos saludos a Montreal, mandamos saludos a Austin. Aquí Jess también manda saludos a Guadalajara. Y yo mando muchos saludos a Viena con mucho amor. Vamos subiendo ya 657 metros. Estos peces son muy típicos a grandes profundidades. Hay veces que cuando los vemos a 2000 o 3000 metros parecen inertes, y una vez que sienten la corriente empiezan a moverse, pero bueno, este parecía muy activo. Bueno, esto nos recuerda un cielo estrellado, si acaban de sintonizarse. Vamos de camino a nuestro siguiente punto de muestreo. Recolectamos 10 push core. Unos no pudimos recolectar porque el sedimento estaba bastante blando, pero bueno, ahora vamos de camino al siguiente punto de muestreo. Gracias a todos los que siguen conectados. Es un privilegio estar observando el fondo de este océano cerca de las costas de Uruguay. Les recordamos que todos este material, estos live streams, estos videos son muy importantes para acercarnos más a entender lo que está pasando en el fondo marino. Sabemos que es el ecosistema menos explorado en el planeta. Alrededor del 5% se tiene cartografiado o mapeado con sonares, y menos del 20% con alta resolución. Pero sí, o sea, el fondo del mar es de los ecosistemas menos explorados en nuestro planeta, sobre todo a altas en profundidades más de 1000 metros, y siguen sin conocerse. Por eso es tan importante este trabajo que se hace, que se realiza. No todo lo que estamos viendo nos proporciona un detalle, un análisis. Podemos realizar un análisis de los procesos que se están llevando a cabo, como por ejemplo alta tasa de sedimentación, materia orgánica, etcétera, presencia o ausencia de diferentes organismos complejos, de peces, de estrellas, de cangrejos, de calamares, invertebrados. Like this area over here, like we haven't gotten there yet, but like areas where there's like patches, those will be like But yeah, we can wait until we get to the waypoint and see how it looks like.
Hay una pregunta si en el fondo del mar se forman dunas en el sedimento parecidas a las de los desiertos en la superficie. Es una buena pregunta y de hecho sí, normalmente en los ríos y en las profundidades menos profundo como en la costa, pero aún ayer si estuvieron aquí vimos algunas como dunas que forman a causa de las tempestas, pero aquí probablemente no, típicamente no tenemos corrientes suficientes fuertes para formar las dunas aquí.
Sí, con respecto a lo que mencionaba de los corales, había una pregunta acerca de por qué no vemos corales a esta profundidad. Yo me refería a los corales formadores de arrecife, pero sí, hay corales a estas a profundidades 2.000 o 3.000 metros. Y esos son los corales que viven a estas profundidades con poca luz y baja temperatura. vamos a preguntarles al team de ROV, porque el Falkor ha estado en diferentes expediciones y bueno, yo recuerdo una del Instituto de Ciencias del Mar, del CSIC en España, donde estaban muestreando a unos 400 metros de profundidad en las Galápagos y también encontraron arrecifes.
So you left this one on, it's not purely, so the other one couldn't do it. So let me know in half an hour.
It's feeling better. The top one is this one? The bottom one is this one.
This is those four, and the bottom one is the middle. Perfect. But the middle one we can't fix till you're not in it.
Oh, right. Thank you. It already feels better.
Placebo effect.
I have the will to live again.
Pues sí, si no hay un sustrato, una superficie dura en el fondo, las larvas no se pueden adherir y por lo tanto no se pueden formar estos pólipos que empiezan a secretar el esqueleto de carbonato de calcio y por lo tanto hacen la formación de estos corales. Aquí, como pueden ver, no sé si recuerdan, el primer muestreo, el sedimento es bastante flojo, incluso los sedimentos se caían del push core. Así que la diversidad que vemos en esta zona son peces. Hemos visto camaroncitos y ya nos acercamos un poco a nuestro siguiente punto de muestreo.
What was it? I haven't seen him. The sea lion keeps making its way around. I mean, I got it earlier. When you said it was all profile.
Oh, on RV. This guy just wants to.
Very cute. They're like one of the older living fish. Yeah. I think it's the warty.
Really is a word.
Mhm.
210 years.
Wow, this is a bad.
Yeah, if that's important. Or, oh yeah, excuse me.
Ya casi estamos llegando a nuestro siguiente punto. Buscando un sitio para muestrear. vemos más aves marinas en la superficie, un ambiente contrastante. Oh, where is that? Yeah, we're almost there.
It's like they 100% are.
Are we there?
Yeah.
Okay. So let's see. Yeah, what is this? Upscaling?
Yeah, I do not know what that is.
I would like to try maybe next to, well,
Sit down and maybe get a clear shot.
yeah, I think before that, should we fire the other Niskin bottles before it gets to, yeah, so let's do 3 and 4.
And you want 1 meter altitude?
Sorry?
1 meter altitude.
Yeah, that's fine. So, Niskin bottle. Mm-hmm.
We're about 1 meter and a half altitude. You want 3 and 4?
Yes, please. Mm-hmm. Got that. Okay then, 3 and 4 Niskin bottles.
Yes, got that. Thank you.
Thank you.
Alright, and then you want us to look at the biocuration thing? Those marks? And these will be the starboard
Yeah. Although there were 2 that we couldn't get on the first side, but it's 1 and 2.
on the port side.
Yeah.
I know.
Let's see if we can.
And anywhere around here, or do you want me to look for that trail?
I think it's getting difficult to see. We can try maybe, well, it looks pretty similar. Yeah, we can try those. Mm-hmm. Subimos a 612 metros, estábamos casi a 800. Ahora vamos a proceder a realizar nuestro siguiente muestreo. One and two.
Just these two.
Yeah, we did the other ones on the previous side, but these were empty.
Right, I say we don't do anything on the starboard side here.
Well, on this side, no, just one and two.
I know. But
On
you
the
do
starboard
anything on
side,
the
yeah,
starboard side.
the other ones, the rest of the basket, I.
Okay. Go all the way in.
Yeah. They look pretty fluffy. I don't know if we're gonna be able to get them. Yeah, and then proceed with the other ones, yeah. Mm-hmm. thing.
Wow.
All right.
Oh, yeah, it's gonna come off.
About the most humbling noise. That's what I would say.
Yeah, so the top right now, not going up, it's just like pressing out. So this is no resistance at all. Yeah, so you can't overcome the you could do a little bag instead of itself.
We could do a bag. I think I would rather try another side. What we did last time, it was like a black patch. If we can see something similar and try there, I would do that before trying the bag. So maybe we can try to see if we can get another side, and if it's not possible, then we just do the scooping.
Also just to see how the gliders work. Go up the canyon that way. Everyone's coursing. Running close to the canyon.
Yeah,
I'll
it's
tell
very.
Yeah, okay. Can you just go up and tell us something quick? So of course it's on this one. Just this. Yeah, we're gonna fill out.
It's very loose.
Then go up the canyon wall and let's see get out of this fluffy stuff and see. Yeah, it's just get out of the canyon and try to get as much up there as you can. Yeah. I'll be back as soon as we're done with this meeting.
Val, did we get it? Did,
We got push core number 2.
okay.
WMS, whatever it is.
So 1 is now considered full. Sorry.
Sorry, that was push core number 1. That
Yeah.
was.
Oh, that was 1.
Yeah.
Okay.
Yeah, sorry.
That's okay.
And number 2 that was the one that got lost.
Okay.
I think they might have put them back in that way. Yeah.
So we're gonna cross off.
Yeah, the other ones are marked down.
Right.
It's very possible. So you want us to look around while we mosey on the next bit, right?
Yeah, yeah, yeah.
Ready?
Ahora vamos a buscar otro sitio porque aquí está bastante complicado. Los sedimentos están muy blandos. Bueno, vamos a tratar de encontrar una zona donde podamos muestrear y vamos a subir un poco más. Vamos a salir del cañón porque hay demasiada materia orgánica que se está depositando y eso hace que los sedimentos sean muy blandos. Vamos a explorar un poco, pero dirigiéndonos hacia el siguiente punto de muestreo. Yeah, I think it's gonna be the same. It looks really soft. I mean, all of those holes and cracks are. Yeah, no, we can just start heading to the next point and see if there is. Mando muchos saludos a la estación experimental de Aula Day, que me están escuchando, a Ernesto, a Bruno, a Ana Casas. Les mando un saludo muy grande, transmitiendo desde el ROV Sebastian a 600 metros de profundidad. Y bueno, gracias a todos los que siguen esta transmisión. Estamos explorando un poco este cañón que vemos que tiene una gran cantidad de materia orgánica siendo depositada en el fondo. Y vamos subiendo a vamos subiendo un poco. Sí, vamos camino a la otra estación, probamos hacer un muestreo, pero los sedimentos estaban muy blandos, se caían del Pushcore. Y bueno, ahora nos dirigimos hacia nuestro tercer punto, que es arriba de este canal. Do you think we're gonna have better luck above the channel, Kaylin?
I think so. I hope so.
I hope so. Y gracias a todos los que siguen pendientes de estos live streams, de la expedición. Una vez que acabe la expedición, todo el equipo, todos los diferentes grupos estamos comprometidos a la transparencia de los datos para poder hacer públicas toda la información que se tenga recolectada de estas expediciones para poder justo proporcionar esa información de estas zonas que estamos mapeando, que estamos analizando. Creo que fue una jellyfish por ahí. Seguimos subiendo el canal. Bueno, me van a disculpar por el ruido, pero voy a tener que comer algo. Kaylin, what's the most exciting thing about this expedition that you can tell us about?
Just getting to see these sedimentary environments in person. Not quite in person, but as close as possible to in person. I mean, it's pretty exceptional. These are hard to observe. We teach about them and we make inferences about them, and we can see them preserved in the rock record, but we don't really get to see the processes.
Happening in
observe
real
the
time.
processes in real time, yeah. But just generally being on this mission with a bunch of biologists with different backgrounds, exploring this really fascinating question of the origin of complex life. Very fortunate to be here.
And we're very happy that you joined us in this expedition and give us your background and expertise. It's really amazing how it all comes together, different approaches and different disciplines.
Thanks, Val.
It's gonna get wild. Adrenaline rush. Did you get any cores there? No.
Just one little bit.
Okay, great. I think it'll be better up when we get up. Yeah. I hope. I don't know. We'll see.
Yeah. So let's ask Chief Scientist Brett Baker, what is the most exciting thing about this expedition you've been so far, that you can tell us so far?
One thing?
One thing. Like that caught your attention the most.
Man. The quality of the close-up videos when we're diving and ascending from the ROV.
Yeah.
Yeah, because in the Alvin sub before, the
You
thing
don't
just
get
sinks
to
like a brick and you can't see anything.
Yeah.
I'm not used to being able to see all the stuff in
All
the
the
water column.
detail.
Yeah.
Bueno, eso es parte de las respuestas que nos han dado, que es lo que más les ha llamado la atención, la calidad de los videos, las imágenes que podemos ver en el ROV, en estos live streams, es realmente impresionante. Hemos estado en el submarino Alvin y aunque podemos verlo en la ventana al momento de descender o al momento de ascender, no ves con este detalle con el que lo vemos en estas cámaras del ROV Sebastian. Que le comentaba los procesos que están pasando en tiempo real, la sedimentación, los procesos que estamos viendo en este momento, cómo se está depositando la materia orgánica, el tipo de sedimentos que tenemos, la consistencia, el poderlos ver, el poderlos procesar, ¿no? Eso es muy emocionante para los que trabajamos con el lodo. Me pregunta el piloto Chris que si a mí me gustaba jugar con el lodo de pequeña, y la respuesta es que sí. Es bastante obvio porque estoy llena de lodo la mayor parte del día una vez que procesamos estos sedimentos. Y bueno, seguimos en búsqueda de un sitio para mostrar. Nos estamos dirigiéndonos más arriba, como pueden ver en la transmisión, ya la profundidad, estamos a 590 metros. Y nuestro primer sitio eran alrededor de 800 metros de profundidad. Y bueno, vamos a ir subiendo un poquito más hasta llegar hasta el siguiente punto. Gracias a todos por seguir aquí. And we do have a question about why we leave the tube in the dirt or the sediments for a bit. And this is for us to get an idea of the sediment distribution and the geographic localization. Sometimes we need to pair data in oxygen profiles and rates and measurements in cores that are next to each other, so we need to have a clear picture of the number of this push cores in the sediment. And yeah, we don't want to disturb the sediment until we're ready to collect them, so that allow us to make decision when it comes to core allocation and who's going to be analyzing what, depending on whether those sediments are going to be used for culturing, for metagenomics, for lipidomics, for dating organic matter and pollutants concentration. Excuse me. And thank you all for your questions, your engagement. We're really happy and excited to be here. And thank you for being pending and engaged in our live streams. We encourage people to ask questions, and we are trying to do our best to respond while we also make decisions about sampling points and sampling sites.
The top is like 200 meters or something.
Vamos subiendo poco a poco el cañón. Como ven, la profundidad también va disminuyendo.
Pretty exciting what we've seen. I think I had another waypoint.
Yeah, we're heading.
We're not going there. Let's get to the top of the camera. Try and get some colors.
As soon as we get there. Just like here.
Sure. Yeah, wherever you want to do it. What do you think? You're in charge.
That would be a question for the ROV team. What do you think, Alex? Have you seen a doomsday fish?
I haven't been around for one. I don't know. Have either of you seen like an oarfish or a ribbon fish? Yeah, subsea. Nah. Yeah, it sounds like a no on our current pilots across. Chris, like, absolutely not.
Absolutely not.
Yeah, no, it'd be really cool. That'd be really fun to see, like an oarfish or a ribbon fish or a herring king. We did have the, entirely different body type, but we did have a mola circling the ship a little while ago. And I know a couple cruises back they had molas, like kind of near the ROV itself. So those are cool. We've had like mobula rays in the past as well, kind of come check us out. I would love to see something like an oarfish or a ribbon fish though.
The mola was very big, right? Was it like a...
You said they get like 300 pounds.
Wow.
Yeah, they can get quite large. Yeah.
Yeah, this one was big. It was like...
Yeah.
Are you next?
It's the IP for. It's the IP for landing.
Yeah.
No, the.
Oh, the IP. Yeah, sorry. Oh, here it is.
I know.
Back in the sauna.
Nice.
Yeah. Try saving out to the easy. Try to reduce our carbon footprint.
I had some trouble to get it.
Sí, vimos un mola, lo pueden ver en el live stream. Tenemos imágenes de lo que estaba pasando en la superficie. Vimos unas aves, vimos un mola, vimos una foca. Y bueno, ahora toca el cambio. Se quedan con Jacob. Y muchas gracias a todos por sintonizarnos y por estar al pendientes de esta transmisión. Y un saludo muy grande a todos.
This is when we deploy them. This is when we collect them back into the. And then
This one, all of these are done,
skins 1 through 4.
except yours.
Asgards.
is empty,
And if you want,
and this is
that's
empty.
the most important stuff.
Here.
I really didn't do much. I mean, I did a few fish.
And that's filtration, is that right?
Yeah, and I had to correct one of my push core ones, but otherwise, you'll have to do the next push core.
The rest, including yours.
Thank you.
Yeah. Yeah, there was something. But it will be number 1, and then the rest you don't have to do the 19. If we can just do 17, it will be fine. I mean, if they are, if they are look at it, they're coming out.
We don't want to put that temptation.
Try to do it again. So. Yeah. I think that would be it. Yeah. Here's the notes.
This guy.
Sorry, saw shirt.
So yeah, we're probably still on turn 8 for okay. Depending on how the coring goes on things like this. It's all on top of now.
Hola, soy Jacob y la otra científica en el cuarto de control es Laura. Vamos a cambiar los pilotos ahora mismo. Momento.
Should I put it in here?
Oh, you're not on the station.
Oh my god, oh my god. No, it's alright. People must be nervous. Waited until right when it was time to sit down and run away.
I got another minute. Once in a blue moon, I feel the AC kick on. I know. And then it's right here. Right here is okay. Yeah, but then it goes away. Yeah.
También en la sala está Ceci Alonso, que quiere pasar a saludar. Bueno, cuídense mucho. Hasta la próxima.
Oh yeah. How was that? Floating.
I would say they're for lunch, not
Ahora conduciendo el vehículo son Chris y Mike.
With the starboard arm and not their pump.
Y
So we're
Alex es nuestro correspondiente. Y Ceci es nuestra heroína porque ella puede hablar español.
Pero se aprecia mucho el esfuerzo, Jacob, que estás haciendo de transmitir en 2 idiomas.
Sorry. Estamos subiendo al pared de la del cañón. Hemos encontrado un cangrejo. Y arriba del cañón vamos a colectar más sedimento.
podemos ver mucho y mucho de que se llama nieve marino.
Tal vez para quienes recién se suman a la transmisión, le contamos que estamos en una campaña en aguas uruguayas en búsqueda de nuestros ancestros microbianos. Estamos buscando a un grupo de microorganismos que suponemos son los descendientes de una célula llamada Archaea, que se asoció con una bacteria, con otra célula de bacteria, y a partir de ahí se generó toda la vida compleja, todo el árbol de la vida que conocemos, que podemos ver, todas las plantas, todos los animales, todos los hongos. Y las estamos buscando aquí por las características que tiene nuestro mar, que es un mar muy rico, como ustedes pueden ver en las imágenes. Todas esas partículas que están ahí son alimento para todos los organismos que viven en el mar. Y como decía Jacob recién, se le llama nieve marina porque, como ven, es algo que va cayendo desde las capas superiores y así se alimentan los organismos a lo largo de toda la columna de agua y también en el fondo.
Anémonas. Creo que son anémonas verdaderas, no son corales o algo así. Anémonas, un tipo de nidario relativos de las medusas, pero sésiles y viven en el fondo. Que la relativa o la medusa.
Y bueno, esta estación en la que estamos ahora es muy especial. Por lo que hemos visto, hay muchísimas formas de vida que ustedes también habrán visto a lo largo de la transmisión, tanto en la columna de agua como en el sedimento y también en la superficie. Ha sido un día de muchos avistamientos. Tenemos una compañera que se llama Lucía, que es la que está haciendo la parte de observación a bordo, ayudada por Gabriela, que es la observadora del Ministerio de Ambiente, pero que también es bióloga especializada en grandes animales. Y entre las dos están haciendo observación. Y hoy, por ejemplo, se vieron ballenas, se vieron peces luna. Hubo un pez luna que lo pudimos ver desde todas partes porque estaba muy cerca.
Focas elefantes o lobos, no sé cómo se llaman, lobos o focas elefantes.
Sí, lobos marinos y también hubo un elefante marino y muchísimas aves.
Tyler, do you know what those fish are called? The short ones with the oscillating fin. Sorry. I know what Tyler Havens. I keep mixing it up. Sorry. Alex, do you know what kind of fish those are? The short ones with the oscillating dorsal fin.
Yeah, they're Oreos.
Huh.
I know that one. I know that one.
That's short for something?
Not just, there's like a group of them, but it's Oreo, like related to I just want to know one side.
Huh. That's the genus name.
Stay in the middle.
It's Oreo.
It's really cool. And that's why I'm sitting here, because there's a little bit of a...
Yeah, can you put up the high temp probe for the control room?
Yeah.
Yeah, they're
This is all.
Oreo sonatidae.
The big ones.
Thanks.
They're pretty long-lived fish.
So that's it.
Por Alex, los peces se llaman Oreos, de una familia Oreosomatidae.
that one should be able to do the whole point of having two.
Okay, sweet. Awesome.
I'm gonna fit that one. I mean, around another
Okay.
like hour.
Okay.
This diamond.
Okay. Thank you. Can you feel it?
I saw two of these guys earlier.
Oh yeah.
Hmm.
I mean, there's something.
This one?
Is that a sebastid, like a rockfish?
It's only giving.
Looks like it.
It did.
There's something wrong here. What's wrong here?
I don't know if they don't. Yeah.
I don't know. I don't know where you're getting that.
Oh, I mean, this is cold. That is cold. That's on and off occasion.
This one, do not turn on.
Okay. I have on my wall.
Don't turn this one. And
Okay.
Which one?
Here.
don't turn this
The
one on.
main one?
Yeah.
Taking that
Oh,
off.
cool. We're just cooking.
No, because it's currently giving out hot air.
That is true.
So if you keep it on and it gives out hot air,
Yeah.
then the other one, which is the
Hmm.
side ones,
Can we investigate that hole?
can't.
Oh, somebody's in there.
I mean, you do have some stuff there.
Look at the sky.
Don't really crab in the hole. Looks like limestone.
Yeah, it
Sure does.
And then I. Oh wow!
What is that?
Planarians, flatworms. Whoa! I think that's what they are. Maybe ribbon worms. No. I can tell you they're not annelids.
Can't collect anywhere.
Those are, if you annotate animal, those are other. Or maybe triple question mark.
That's right. I forgot that was one of the options.
That's great too. Thank you.
Keep that waypoint moving on. Moving knows not to stop it.
We actually have a little camera on the manipulator, but it's not very high resolution, and I think it would be a very bad day for that crab, and maybe for us, if we stuck the manipulator in the hole.
They did
Oh
like
yeah, no,
one
that's way too small for that.
Okay, wait. RV Bridge, you happy with the speed? Are you happy? Yeah. I was waiting for
Hmm.
it to catch up a little bit.
Yes, they are very happy.
Spoonworm, it's a possibility. Hmm. Yeah, interesting geology. You said you've spotted a few of these spots already?
Looks like there's a few.
Oh, here, yeah. Yeah, it looks like there's a limestone bedrock under this.
Interesting.
Could we zoom a little on the back of the crab, please?
Oh, he's covered in barnacles.
Yeah, do you think those are parasitic? They're no.
Yeah,
I mean,
there's goosenecks.
yeah, I was going to say I'm not aware of any crustacean parasites that are goosenecks. What's going on with its left claw?
Yeah, it was covered in
No
like
idea.
leeches or something.
Like you just stirred up a fizz.
What did you think it was on the claw?
Well, it was fuzzy,
Yep.
but not white. We've seen critters covered in leeches.
Really, like oh, I'm forgetting the family name, like proper leeches.
Yeah.
That,
Yeah. Down further south, we kept seeing oxygens covered in them. Not to that density down
Mhm.
but
Yeah, where the crab holes, it's limestone. Kind of surprising.
I mean, at least limestone is the word we've been throwing around. Does that seem right to
Well,
you?
it's white, it looks like it.
Yeah.
It's a white rock.
An interesting snail.
This is what happened last time we were going up and started seeing these crab holes. And then
It's like a carnivorous snail of some kind.
Amazing how much is certain
That's all right. You don't have to land it.
Sped past it.
You don't. You don't have to land it. We're gonna blow it out.
We're not going to get
Did
We are. Yep. We've done it now. What's ahead of us?
either somebody walked off with a written dive plan, or I don't have one. Do you know when we're trying to trying to take a second set of samples?
One I can. It's so when we get to the top of this, which I think is around 400 meters, we're gonna go to the core and ascend. That'll put us. Yeah.
Okay. I mean, I'm not too worried about running behind schedule because you're here, but
Yeah, no.
otherwise that would be.
We weren't able to ascend this course and get up to the top.
We'll probably have to stop for the course. Well, how long did we say it's going to take us to come up, Jules? We'll have to allow like
30 minutes, so it'd be like an hour to get up there, probably. Something from like 4 hours or so. Yeah. And we're at after 2 now, so.
we need to allow for probably half an hour at least for doing the course.
Yep.
Which course you
Yep.
got to do?
So we're just the core within the next 15 minutes.
Yeah. It looks like dispatch took about a half an hour.
Literally, yeah. When we get to 2:30, you start calling. So,
Keep us right, because I'll lose
Yep.
track of time.
I would.
Mm-hmm.
So you happy just heading on this trajectory, or do you want to head
that's
more
good.
north? Or?
No, that's good.
I'm just looking at now the vessels. They're going quick.
Por cierto, las cuevas son hechas de una piedra con alta porosidad. Creemos que es limestone. ¿Cómo se dice limestone, Ceci?
Caliza.
Caliza de las conchas ancientes de animales ancientes. No de acción volcánica aquí, pero parecen similar que pomes.
Bien, the winch.
That's an opaque.
Wait, thank you.
Stop at that, yeah.
Yeah.
Mm.
Still down there.
Nice.
Well, village.
Could we
That's
please?
going
Oh.
fast, and the bell spout's going to follow us.
Oh.
That's our wake.
Yeah. We're just whipping along quick and slamming the brakes, unfortunately.
Yeah.
The vessel's still moving as well, so I think it needs to keep up with it.
Uh-huh.
Polycarbonate is hard ground. Which can be very low sedimentation.
You can stop one of this and then keep us at the spot. So that.
I'll leave that to Brett. Do you want to stop the ship? Is this an interesting enough spot to, or you want to keep moving?
Going right now. If it starts doing a lot more of that type of stuff, you might want to slow down and we can stop easier. But yeah, just go. I'd say just keep going fast. If it starts to get we start to see a bunch of stuff. That may have just been a one-off though.
You can get the vessel to slow down just a fraction.
Please, LV, please slow down coach.
Sorry, no.
How do you not get dizzy flying like that?
I prefer it. I don't like following straight lines. Meandering. Forever.
Coming over the crest. Ceci, ¿conoces qué son merenguitos? Merenguitos por chat. Hay un tipo de animal, tipo de invertebrado que se llama merenguito.
Pero me imagino que eso debe estar de otras expediciones que se le ponían nombres así. Pero no había los merenguitos.
Oh?
There you go.
Yeah.
That's the second one.
The
Yeah.
elasmobranch fix.
Langostillas.
Oh.
Sí, no hemos visto.
In English, I think we would call this a dogfish or a smoothhound or some such. But I don't know the local sharks. Do you want to get all the way up and over to the second waypoint before we sample?
We're gonna stop for 9 minutes.
Oh.
Wherever we are in 9
Got it.
minutes.
There's that looks like a cusk eel in your lower left. Alex, is there any chance we can do flutter mouse PIP so people can see where we're going?
Just flutter mouse up where?
Like up in the upper right. I just think it's a nice view of. Give people some orientation, if it's easy. So we've just crested the edge of the canyon. And, we're going to transit for about 5 more minutes and then take our second set of samples. Thank you, Alex, for giving us our bearings. Got it for him. Ooh. Yeah. Like some kind of polykey. Yeah.
Hopefully if you go too fast for
On a schedule.
stops.
There are many of these hydromedusae down here. Ooh.
What is that? What is going on there?
Detritus flow. Can we suction it?
Right there.
Can we suction that? That would be probably not.
Do we want to do that though?
Why not?
Totally
No,
want
it is.
that. Why not? If we can, we probably won't be able to do it.
Well, if it keeps drifting, it'll come out of this cloud.
Yeah. Tenemos un gran nube de material floculente. Vamos a succionarlo porque
Yeah, please control stop.
porque
You managed off with that canvas? Yeah.
podría ser un megalópolis de microbios.
There's nothing else. Clean things up a little bit.
Yeah. Lower left.
Oh yeah.
Federico.
Whatever it is,
Clean that
will
mess
soon
right up.
infect our
Yeah,
boat.
sure, yeah.
Yeah, this is how the thing.
Yep.
Sure, it's gonna smell lovely.
Yep. That's crazy.
Yeah.
It's like a floating biofilm.
Yeah.
Sweet. Well
There's
done.
some in there.
Yeah.
Well done.
Do we have, okay, is there a light on the, can we get a light on the suction bucket, please?
Yeah, it's
on. Oh, okay. I mean, it's in there.
Yeah.
It's cooling off though.
Yeah, you can see it around it. So cool.
awesome.
Wow.
We'll get some in 8 and 1. Just to make sure.
Maybe
You happy with that?
Yeah,
Mhm.
that's great. Maybe just scoot up to a clean spot and try and pull some mud. Hopefully.
It's one of my earliest mentors, the aquarist at the Santa Barbara Aquarium, said mucus makes the world go round. It's true.
The
And that was the number 8, was it? The bucket?
Number one.
Number 1.
SS1.
SS1.
Yeah, so we'll put some in 1 and some in 8 as well.
Okay.
Just because I like to make sure that the
We'll
jar is
do the rest of the Niskins too for you then.
Okay.
I don't actually, nobody marked off the Niskins here. I forgot to ask, what's our Niskin status? Did we fire the first?
1 through 4, yeah.
Thank you.
That's the other presentation.
Five.
And 6.
We're going for this. All this.
Yep. Yep. Whatever's left. That,
honestly.
you might want to ask Mike
No,
about that one.
let me see. No, there. Where they go.
Yeah.
Two's questionable. It's even. It's
Yeah,
working properly.
just do the right side.
Yeah, just do that. Okay, so
Yeah, just try one, see if we can get anything.
so anywhere in
Anywhere that feels good to you.
Yeah, we might want to get clear of some of this rock.
yeah, the rocky bits we want.
You mentioned scooping?
Well, let's try and core first.
Okay, so how about where do you think the two go?
Can we swing a bit to the right, please?
Okay. A lot all along, so I'm kind of trying to match the hill because it'll be
Sure.
a bit easier.
I'm just trying to get a handle on what these little white patches are. Looks like by observation.
See the word no.
Go ahead and email.
Likewise, Brett, if you want to call a landing. I don't want to be anywhere near a hole.
Yeah, I agree. What do you guys think? You guys are more experienced coring.
Yeah, just see how it is when you
Yeah.
land. I mean,
See a bit of topography there. That's actually that looks interesting. What do you think of that, Brett? That little crack. I mean, I don't think we want to sample it, but it is interesting.
I'll get it in the range of the minutes and
Yeah.
so get
Okay,
just
well, yeah.
normal.
Great.
Yeah.
Yeah.
Okay. So
Let's
so
touch down
things are
here,
good.
please. That looks fluffy.
Cheese. Okay. Right. Okay. Yeah. I'll kind of email Alice again.
Wow.
¿Sabes si este cañón tiene un nombre?
Sí, todos los cañones principales tienen nombre, pero no sé enfrente a dónde estamos, no sé en cuál estamos, pero sí.
So we have some options here, Brett. There's this little fissure. We'll have to wait for some of the dust to settle. You can see it in the sit cam. There's this little fissure in front of us, which is kind of interesting, but not that homogeneous.
Yeah.
So we can core either beyond it, or we can core through it, or both.
Core through it.
We'll start at the back and work our way to the front.
Yeah, that works.
So start where you are and we'll work our way at the front and we'll do 2 rows. So give yourself a bit of space. Make sure you've got enough to do 2 rows. Well, if you start there, it's better to start in the middle and work your way back to your arm, because then you don't have to come over once you've already done. You know what I mean? It's better to start here, work in, and then work back towards your whale, because then you'll clean it all in.
This should be the last one.
Yeah, yeah, furthest away. Right. But let me know when you're ready, and I'll have to maybe flush down as well while you come down. And then at the
Just to
bottom,
belatedly
when
double check.
When you go all the way down, freeze your arm.
Did you get to mark section sample 1 and Niskins?
Neutralize any motion.
Oh, the Niskins? I didn't. 5 and 6?
Yes.
Are you ready?
Shit, I missed that.
You can put
Okay.
a late entry.
Okay. I'll do this first.
You want it all the way, or just leave a bit at the top? Leave it there?
I think let's go all the way. It looks fluffy. Estamos unos 200 kilómetros hasta la costa del Uruguay, al lado de un cañón, pero no sé el nombre de este cañón. Ceci está buscando este nombre ahorita mismo. You see 1, 2, and 1, 3 deployed? You've got it.
Yeah.
Just make sure you don't use this sample. Like, actually, you don't want to log the samples until they get back in that curve.
Everybody was logging deployment and.
We have a separate button.
Okay, separate one.
Yeah, I
To
did
use
the
a separate button.
deployed, yeah.
Great. That's what I meant. That one is an observation. The other one is a sample.
collecting our second set of push cores right now. We divided the 19 push cores that Sebastian is carrying into 2 sets today. And shortly after this, we're going to head towards the surface. It looks like the sediment's pretty fluffy at this site, like it was at our first. So there's some suspense.
You help me to go that lost that trench.
In the crack? Yeah.
Yep.
Go for it.
In the crack.
Yep. Yeah, there are a lot of different scientists on this expedition who are doing different analyses. So some people are plunge freezing, which is extremely rapid freezing of the samples so that they can do a certain kind of microscopy and actually visualize microbes that are living in the sediment matrix. Other people are extracting DNA. I'm extracting membrane compounds, and then, I mean, that's just a few samples of the long list of people, things that people are doing with this mud. So, in a sense, it's just quantity. We don't have one large box core that we can use to sample a large area of mud. So we're sampling a large area from the same site using multiple push cores. It's also convenient because once we bring all these push cores up, they can be divided among the different scientists on board. But the idea is we want to be able to connect our findings to each other. So if, for instance, somebody found an interesting group of microbes in the DNA, and I found an interesting lipid membrane chemical compound, and Luke saw a really interesting microbe in a high abundance in his electron microscope, you might be able to correlate the three together and look into whether we're picking up signatures of the same thing in the same place.
Out and just lay it down, it might be easier. Let's see if it keeps.
I'm sure.
Right in line for where you're trying to land these things in.
Well, I take it out one side.
Side of the crack or still in the crack?
In the crack's fine, like the yeah, that's good.
I mean, one thing that I think would probably be important for myofauna, which is to say, that's the fancy word for critters that live in the mud, many of which are bioturbators, which is another fancy word for creatures that stir up the mud. A lot of them have to be able to work with really low concentrations of oxygen. So that might be an example. You know, we're used to say 21% oxygen in the air, and we start doing pretty poorly when that gets much below, 18 or 15%. A lot of animals, not just in the mud, but also in the midwater in the oxygen minimum zone, can pick up oxygen out of the water even when it's very scarce. Oxygen gets scarce in the mud quickly because water doesn't flow through the mud easily, and there's also a bunch of microbes and things in it consuming the oxygen. So that might be one example. These species are also going to have to develop resistances to chemicals that show up in anoxic, oxygen-free mud that can generally be toxic. One's called hydrogen sulfide. So if you've ever dug mud out of an area that doesn't have much oxygen, like
like a mud flat or an estuary. You might notice it smells like rotten eggs.
Somewhere.
And that rotten egg compound is hydrogen sulfide. In high concentrations, it's quite toxic. It actually can have effects sort of similar to those of cyanide. It gets inside the mitochondria, the powerhouse of your cell, and stops it from generating energy. Anyways, we don't exactly know all the ways that bioturbator species are resistant to chemicals like hydrogen sulfide, but a lot of them clearly must be, because there's a lot of sulfide in the mud and they live there. Great question for Ian, by the way. If you get him on the stream later, he was on duty, I think, some 4 or 6 hours ago this morning. And he is an animal microbial symbiosis biologist who studies things like clams, which are bioturbators. They live in the mud. They pump water.
Wherever you can make it work.
As for the question about the push cores, backup is definitely not a wrong answer either. You can tell that they don't all work, so we can hedge our bets by taking more. The anoxia happens basically because water fills the pores in the mud, but it doesn't flow through those pores very easily. Meanwhile, there's a bunch of life in that pore water and living on the particles of the mud. So microbes, and there are animals down there too. And they consume all the oxygen. So they're basically consuming the oxygen faster than it can move in from the water over top of the mud. And the end result is that the oxygen gets drawn down pretty low.
Happy with that screenshot?
Laura, were you able to get cores deployed? Check all of the above? Yeah. Okay, do you have a cores deployed annotation? Great, thank you. Yep, we're happy. Thanks. Moment of truth.
You could have it too steep, you won't have the height. You could have it like a little bit flatter. Yeah, 45 degrees is the best.
Asgard Archaea are a subgroup of Archaea that are probably our closest simple-celled relatives. Brad Baker, one of the world experts, is in the room, so I'll speak to it.
No, probably.
There you go.
What was the question?
It was just asked what Asgard Archaea were.
Oh, okay.
You don't suppose we'll ever find a group closer?
Yeah, that's a great question. So Asgard Archaea, just to say it again. So Asgard Archaea are microbes. Oh, there's a whale. Might have a whale pop up on the screen here in a second. We saw we'll see. Anyway, yeah. I think it's a whale.
Yeah,
Yeah. Oh, it's a bunch? Nice. Okay, see you later. Anyway, there's 3 domains of life: eukaryotes, bacteria, and archaea. Within each of those, obviously, there's a bunch of branches on the tree, different taxa, different lineages that are distantly related, but within those 3 domains of life. So then within the archaeal group, which are as different from us as they are bacteria, a totally different group. There's Asgard, that were named after, the first ones are found at Loki's castle hydrothermal vent in the North Atlantic, and it was named Loki, and then we found more, and so they named Thor, and so on. So collectively they're called Asgards. The exciting thing about them is they're sort of our missing link in terms of the evolution between ourselves and microbes. So when eukaryotes, plants and animals, first evolved multicellularity, the Asgards were essentially that host, that ancestral lineage. So they're still alive today. Obviously the ones that were just existed 2 billion years ago are different, but by studying them we can learn about where a lot of the building blocks for eukaryotic life came from. So they have a bunch of genes that we have that had only been seen in eukaryotes before, genes and proteins. And by studying those proteins, we're learning about the origins of eukaryotes.
PC18 recovered. Laura, did you get the recovery mark?
Yeah.
Great, thank you. PC16 recovered. Yeah, this expedition is in the exclusive economic zone of Uruguay in the South Atlantic. We're looking for representatives of our closest microbial relatives, the Asgard Archaea. We're looking for them in the water and in the sediment, which is why we're sampling all this mud right now. PC15 recovered. Thanks. I haven't seen any larvations for the past several hours. I think the particle load here is probably too high. But I mean, it's something that larvations are known for those who are listening who aren't familiar with larvations, they're these sort of tadpole-like animals that inflate a mucus house and live in it and use it to catch food. And then eventually they ditch it once it becomes clogged with particulate. Larvations are known for their role in what we call exporting carbon to the sea floor. So the idea is they pick up stuff in their mucus house, they ditch it, and I believe that the house is supposed to sink faster than the particles would sink otherwise. And that takes organic carbon out of the water column and sends it to the bottom. But not being a larvation expert, I can't tell you much more than that. Nice, well. Do you think it's seated?
No, it needs to wiggle a little bit neatly. Give it a little wiggle side to side. It's still sticking up.
La Paloma Canyon. Gracias, Ceci. Gracias a Ceci para buscar el nombre de este cañón. Se llama Cañón La Paloma. Hacia la costa del Uruguay. Ah, there we go.
I always try and just give it a little, like...
Okay, PC14 recovered.
I do that when we take away the mud as well, just to make sure that it's near, like, we break the seal a little bit, pull it out, and we're putting it in, but just trying to locate it on the thing. Boys.
gracias a Cecilia, que sabemos el nombre del cañón. Ella dice que todos los cañones grandes submarinos de Uruguay se llaman por ciudades diferentes en Uruguay.
We'll see, we'll get the last one, and then if it looks a bit higher, we'll give it a little push.
Okay. PC13 covered.
Good colours in that one.
Oh.
These black covers with black. Black and black. I think, I don't know. I don't know that contrast in them. Yeah. Yeah. Yeah.
Get my boots. What the
Okay, PC12 recovered. And 11 is stuck, huh?
Yeah, I think
I heard.
it's, yeah. I don't know if there's something wrong with that quiver, but we did try it a few times. And
I
it
believe you.
didn't seem to be taken either, so I don't think,
Yeah.
I think it's double not working now.
Oh, I thought it wasn't coming out because the check was finally working.
So I don't think the check is working correctly.
Yeah.
I'm not sure, but we can test that in depth. But
Yeah,
then,
yeah.
However, it's been we put it in that one specifically because it was the most awkward one to get back in.
Uh-huh.
So we're like, if we're not using this, we'll put it. But now it's all the way down the back corner.
Yeah, yeah.
So it's not ideal. But yeah, something's not right with it because it didn't come out.
I saw that you gave it 3 tries.
Yeah.
Thank you.
Okay. So that's ready to moth bottom, I believe.
Yeah. Do we need to hit the waypoint, or are they happy with you coming off bottom here?
I think they were happy to get us on deck for 4 p.m.
All right. If you're happy, we're happy.
Yeah.
So, hey, we're happy.
Yeah?
I'm happy.
Cool. Sale vale. Sale vale.
Two nice scores.
Oh. Are Niskins 5 and 6 still open?
No, we fired them all.
Great.
Right, shall
Thank
we?
you.
That's us leaving bottom, coming back to surface. Okay. Alright, let's move it.
All right. Thank you for joining us. Once more. This is Jacob, Laura, Mike, Joel in the control room. And Ian over there? And Ian, can't get Ian. hiding behind Joel. Thank you for joining us for dive 0869 in La Paloma Canyon. We're headed back to the surface. We'll tell you what we find tomorrow, and we look forward to seeing you for the next dive. Hasta la próxima.